I have a little bit of ADD, therefore you can find me in all kinds of formats. But one thing I share with Josh is that storytelling actually helps you learn things. That's kind of like a hack that I discovered. And I've been doing that via writing books or via talking about it, via podcasting. And it's been really good so far. So I only do it because I want to learn. And I hope that I can share a little bit with you today as well, and we can learn together. Are we ready? Not yet. Uh-oh. Okay, awesome. So very excited to be here. Thanks so much for joining me and for not bailing on me because there is a Josh and Louis combo in the lunch session, which is probably awesome. A little bit about me. I'm a DevRel at Cohere. I've been there for 3 years, and I've been also writing about GPT before ChatGPT came out. So I've written a book that became extinct within a year because the models became so good since then. GPT-3 feels like it's been ages ago. Regardless, I've written a manual about it. It was really fun. I also share what I learn on my YouTube channel, and I chat with guests that are plugged into ecosystem like you guys and try to pick their brain on where are we heading with our AI adoption. And today I'm going to tell you a story about a lab, foundation model lab, Cohere, which actually not many people know is quite a scrappy lab. We are typically half the size in terms of the budget and the human resources of the major big labs out there. And we really need to pick our battles in terms of finding our niche, carving out the capabilities we go after, and the design of the models themselves. It's a very expensive operation to create a model. It's a very complicated one as well. And we've learned it firsthand. And I think that helped us empathize more with people that are using the models out there. So let me ask you a question first. How many of you could use some more GPUs? Raise your hand. Okay, roughly 50%. Anybody GPU wealthy? Raise your hand. Not many hands here. So compute is really an actual bottleneck for adoption, especially if you're thinking about the cost of your operation. You not only want the best model, the most capable, beefed up model out there, but you also want the model that you can afford, that will not blow up your compute costs. And it's a tough balance to strike. On the one hand, you won't be able to build with the latest and greatest, be able to customize those models as well. On the other hand, you have the reality check of the budget that you need to comply with. At Cohere, we are working with enterprises globally, and we see that one of the biggest things that they are interested in is also security. So we work with companies like Fujitsu, LG, Cisco. We are backed by many of these companies, and we have strategic partners there. And they really need secure deployments. They're interested in being able to take the model from us and then deploy it behind their firewall. Ideally, there's nothing else going on in between. No back and forth, no kind of data moving in between. And so we do offer SaaS API. We offer our models through cloud, but honestly, private deployments and on-premise, especially like the fully secure private deployments, is the default option for most of the enterprises. So that's why, having that in mind, having in mind the budget considerations and the security angle that the companies need, we defaulted to building the leanest and customizable models out there. And today I'm going to tell you a story about how we've built Command A. We've released this model in March. We are super proud to report that it's on par or higher in our human evaluations with GPT-4o and DeepSeek v3. It's a very powerful model. However, it is also very efficient and very cost-effective. Here's a comparison. 1 year ago, we released Command R, and we followed up with Command A. So on the right hand, you have Command A. This is our demo environment, playground. On the left hand, you have Command R. Command A is much faster. The copy that it creates, it's much more detailed, much nicer. But it's also much more efficient. It requires less compute, actually, even though it's bigger. So today I'm going to tell you about how we have created the architecture of the model and some of the post-training decisions we've made, and also show you how it works in action. I think one of the really exciting things I get to see at Cohere is the end-to-end pipeline of we're building the models from scratch, and then we actually build solutions that are tailored for these models. They are powered by these models. And then we see the real impact, even internally, with the productivity gains and efficiency gains that people have through them. So let's start with the deep dive. Typically, when you have a 110, 111B model, it's the biggest model there is, typically, and it requires a lot of hardware to run. We've managed to squeeze and find efficiencies in all the possible corners so that it fits only on 2 A100s, so essentially 2 GPUs. An example I like to give is that if you want the latest, biggest capabilities, you don't have to go necessarily for an 18-wheeler. You can go for an SUV. Command A is our SUV. The difference here is 4 times less GPUs, which if you are GPU poor or if you are worried about the costs of your LLM deployment, it's going to matter. We're going to talk about 3 architecture designs here. Sliding window self-attention, then grouped query attention, and parallel blocks that were part of the secret sauce that made it happen. The thing that happens when models try to remember every word. They try to remember every token. And because of that, with every token, the keys and values cache accumulates. And very easily, especially with long documents, with longer prompts, you inevitably are going to hit the GPU memory ceiling, and then the operation is going to crash, or you're going to run out of memory. So what we did is, instead of having the model memorize every single token, we have 3 sliding windows of attention, which help us discard the old rows and only keep the last 512 tokens, roughly. And then 1 layer that is global that keeps the full context of the document. It's a little bit like writing a report, but skimming few pages while you do that. So you're efficient, but you have kind of the context of what's going on inside. And the full self-attention makes sure that the context remains coherent. That itself helps us get rid of 50% of this KV cache, which is very painful. Another KV cache save is typically we have a multi-head, and standard models duplicate memory for every attention head. So in typical approach, you're going to have 8 of these. We've managed to make it so that grouped query attention groups them together and then lets them share memory. So instead of having copies for, you can imagine analysts that need a single copy of the memory for their own, with their own file, and instead of making the same copy of the same kitten or whatever else, the document, they are able to use the shared master, take it from their shared library and use it together. That itself also saves us 4 times less cache. And the final thing is the parallel transformer blocks. In typical scenario, you have first self-attention and then feed forward. In our approach, they run in parallel. That helps us make sure that the hardware does not stay idle. So most of the hardware is being utilized all the time. A little bit like instead of first cooking your rice and then going to chop the veggies, you're cooking the rice and chopping the veggies at the same time to save time and get the same result. So smaller memory footprint, faster token streaming, and the same performance. We also have a very exciting post-training iteration, and I'm going to show you a little bit around that. Typically, what happens is you have a one giant model versus, so you take an instruct model, the base model, and then the instruct model after the base model, and you do a monolithic supervised fine-tuning on top of it with a mix of data, and then you arrive at a final model. What we did is we broken it down into 6 different experts. So we have an expert for code, for math, long context, multilinguality, RAG and agents, and safety. And these experts are then merged and polished, and then the command A arrives. Merging the experts is actually quite interesting. So it turns out that it's a coarse operation, but it turns out that once you merge the 2 models together, you're able to retain almost 98% of each expert capabilities, which is pretty great. Then we have the post-training with RL. So after we merge the soup of experts, we then fork it again and break it down into 6 different RL operations. And again, they're all kind of tested using their own metrics. So code is going to be judged by unit tests. Math is going to be judged by the correctness of answers, the accuracy. Safety or multilinguality, they are going to be judged by human preferences. And so each of these, let's say, teams has their own sets of tests and performs and improves on top of their own metrics over time. Once we hit a certain limit, we then merge it again into an RL soup this time. And we see that that itself gives us an additional 1.5 human preference win. You can see that there's like 1.5 preference when here, 2% preference when there. We're really trying to squeeze everything out of this architecture. Finally, once you have the reinforcement learning soup that's merged, we are then doing what our team called a ping pong. So we have the self-improving robust preference optimization. This is a method that's recently developed. It helps to continuously enhance model capabilities and helps with model alignment and robustness as well. So that algorithm passes it on to another algorithm called whoops, sorry. What happened? COPG, sorry. And so as RPO, what it does is it creates the best draft. It generates an answer. It creates the first best draft that it thinks the model should give. And then it passes it to COPG, which then creates a one policy tweak on top of that first best draft. And then it passes it back to us RPO. And then it goes back and forth. They go into the loop until we see that the human wins plateau. So then we stop doing that. We see that in comparison, for example, with GPT-4o, when you go through these phases, you can get, again, extra 2-3% of win on top of everything. And finally, we have our model. We have command A. So this is a bird's eye view of what just happened in the post-training. you can see that it's quite complex. There's multiple phases of post-training, and finally we arrive at Command A. Now, Command A is powering our agentic system for enterprise knowledge workers called North. We're actually using North internally. It's really fun to see how the wins that were acquired in the model pre-training and post-training translate later on to our internal productivity. So you can think of North as secure AI assistant that is plugging into your data and is helping you out throughout the day with your work. It can plug into Docs, your email, your calendar, and whatnot. We built it because it turns out that when enterprises are trying to build their own custom solutions on top of the models, it becomes really challenging. The data sources are usually siloed, and it's hard to create a one system, agentic system that will rule them all. So we started building it for ourselves, but also for the enterprises. And we make it, again, with the security in mind. So it's completely air-gapped. It can be deployed on your premises, behind the firewall. We've created features like role-based access control and integration to enterprise data sources that our clients care about. One example is Royal Bank of Canada. We are developing North for banking. And so we're building it with the financial literacy in mind, and also with integrations with these deep legacy systems that customers like banks or any other customers from financial sector might have. So we're helping to build their own agents with their own workflows, but we're doing a lot of the heavy lifting on the solution end for them. And as I've mentioned, we are also using North internally. Internal use cases, this is my favorite part, are, for example, we have a government affairs expert inside of our company, and he is plugging in North into his email to create briefings about the latest policy updates out there. So as a policy expert, he gets tons of emails about what's currently being discussed in DC, or I don't know, where things are being discussed on the policy level, but he gets a ton of signal or noise as well into his email, and to go through all of that information is painful. So what he is doing is he's using North to curate the briefings based off of his email, and then he distributes them across the team. Another example, Kate is our hiring partner, and she recruits a lot of folks every day. She has multiple calls, she makes notes from these calls. What she does after these calls is she creates a summary for a given hiring manager that is looking for a particular candidate, and she gives some recommendations. So these notes are usually very chaotic. You can imagine what's happening when you're on calls and when you're trying to take notes. It's chaos. She takes those notes, she puts them into North, and she creates nice summaries for her manager. Kasim is using North to prep for customer calls. So he has plugged it, he's the most techie of this bunch. He has plugged it into his calendar, Search, Salesforce, and a bunch of other sources as well. So before a customer call, he gets a full sweep of, okay, this is where we're at with the customer conversation, and this is the context that you should be aware of when you're entering that conversation. Usually it's a work he has to do before any given call. So these are the examples. We have a really nice use case discovery framework. It turns out that inside of your organization, you really need to dedicate some time and space in order for people to figure out what it is that they want to use AI for. And what we do is first we're going to go through a task audit. We're taking a step back, bird's eye view, looking at what it is that we're actually doing at Cohere day to day, which not many of us stop and actually think about what we're doing. A lot of us juggle a lot of these kind of like nebulous responsibilities. So when you take a step back, break it down, look at it from the bird's eye view, you actually start seeing, okay, this feels pretty inefficient, or I wish I would like to have more time for this. But I am blocked because XYZ. This requires a lot of manual work, So once you do that, you're able to then find these use cases that you actually care about, not the shiny ones, not the ones that look the coolest, the ones that actually saves you the most time or makes your life easier. You do that, and then you experiment with the AI to actually help you get there. It's not a given. We're still learning how these systems work, right? We're still learning how to interact with them. We were on a session, on a launch session before, talking about the human-machine interactions. It's still a lot of work, and it's still a lot of exploration and experimentation, and each of us has a different level of familiarity with AI systems and what they think they would like to achieve with them. So you can experiment, and then you report, and we learn from each other. We created this environment called Productivity Lab. We're running sprints, so every month there's a new sprint. We're focusing on a given use case, discover what North can do for us, iterate, and report back. This is an example sprint update. So we're really structured and really took time to create space in our organization to actually surface those use cases and find those wins. And I really recommend that for anyone that's deploying agents within. I had a video here of North, but it's not showing. Let's see if... No, it's not going there. Nope. Yeah. Well, I can't show you the demo, sorry. I wanted to show you a demo of asking North something live about whatever's happening at Cohere. And you would see that it can, for example, plug into my Slack. And then based on the information that it fetches from Slack, create a report about, OK, this is what people are doing inside of that team. This is what's been currently the latest information about a given customer, et cetera, et cetera. So sorry about not being able to do that. So anyway, going back, this is our answer to enterprises that want the secure, efficient agents. First, we're building a beefy model from scratch that's very efficient, that will get you a lower compute bill, but will do the job. And then we're plugging it into a custom agentic solution that gives you a lot of freedom in terms of customizing what it is, what kind of use case, what kind of data source you want to plug it into. If you want, you can learn more about Command A in depth. We published a technical report. I've heard from friends in the industry that it's one of the rare occasions when you can see how much effort is being put into the model that is actually out there, one of the main foundation models out there, and is being used in production by major customers. So if you want to go deeper on the secret sauce, on the methods that I've mentioned, go and check it out. And also find me, connect with me after this. I'm always down to chat about LLMs, agents, and whatever it is that's on your mind. Thank you. Yep, great.
Thank you. Great talk, by the way. I'm a fan, and I'm a GPU poor. Okay. So if you have a couple of A6000s laying around, this way, please.
Great.
So 2 questions to the model. I had to note them down. Did you try out quantization-aware training to even lower or raise the quality for highly quantized versions of your model? And maybe second questions also about quantization is for KV cache quantization. It's also like not so easy to do that with some models because the quality degrades so much. Did you also look into that?
I believe we have tried quantization, but it wasn't one of the main approaches that we went for. We haven't found that it's giving us enough of a win to fully explore it and fully dedicate enough time and effort to it. So I think that would be my answer.
Thank you.
Yeah, no worries.
Hey, thanks. Really nice talk. North is super cool. Now there's a few models coming out that have really large contexts, and the context is also dependent on, or the accuracy is also dependent on the context length. But like O3 is showing really good accuracy at large contexts. So I'm curious how you're mixing context with RAG for North. So are you like, do you have, I don't know, probably this is also a little secret for you guys, but like, how do you determine what to keep in context and what to RAG out for North?
Yeah, that's a great question. And also it speaks to, because you were on the session before, it speaks to this like observing the user behavior and how they want to interact with the model, right? For some people, it's easier to just dump a lot of information in context. For others, it's much better to attach files or have it being plugged into the dynamic connector like Google Drive. Everybody wants a little bit different thing and has their way of going about this. I cannot speak to the details, but we're exploring both kind of, and we're trying to go in both directions. So both be as good as possible with the in-context learning and context length generally. That's why one of the experts is about long documents to be able to actually deliver on top of the long context, which is a problem generally in the industry, I think. And the other separate one is the RAG agent model. So we're trying to really go hard on both at the same time.
Thanks.
Thanks for the talk. At some point you mentioned that the system is air-gapped. I don't know if it refers to North or to the model, but you also talked about how you interface with calendar or with mail. So what exactly is it that is air-gapped, and how would this provide an advantage over, let's say, confidential computing?
Yeah, that's a great question. So the version of North that I was mentioning, the use cases that I've mentioned, were referring back to our internal version of North. Every company that we work with has a version of North that is customized based on their own needs. And obviously, not everybody uses Google Drive. Not everybody uses G Suite, right? Not everybody uses Salesforce, Slack, whatever. So we're building North so that you can leverage custom tools and plug it into custom tools. And yeah, there is no cloud connection that you have to have if you don't want to. And for our clients, most of the time they won't have that. So basically think about it as two different versions, right? One is the North that we've built internally for us to make us more productive. And the other is the same foundations, but we do a little bit of tweaking at the end in terms of the types of data that it can work well with. So yeah, so that's why you can have an air-gapped solution, but also you can have one that plugs into your G Suite and whatnot.
I think we have time for one more. Yeah, we have time.
I'll try to see if the demo works, because I really wanted to demo something. There's no presentation without a demo, but I don't know how to do this. Can you help me?
There you go. You're taking risk. Okay, I get it now. All right. But then we went from 1 minute to potentially more. No, we'll figure it out.
No.
We'll figure it out. We'll figure it out. We'll figure it out.
I promise. It's going to be very fast. Oh. Okay, great. Thank you.
Normally I would have clapped.
Okay, so here is North. And I am the person that runs the productivity lab. We have a Slack channel where we drop in updates on our experiments. And I'm always chasing people for, how did your experiment go? What did you learn? Tell us everything. People are very shy away from telling about things that don't work for some reason. Obviously, things are going to break. We're all like building stuff here. So I'm going to ask, what are people inside productivity.
I'm ready for it. I'm ready.
Up to. And I connected it to my Slack. Let's see. So now we have a recap of what's actually happening live inside of our channel about North. There was a North document creation workshop. We hosted it yesterday. We also have a batch of members, cohort of members, going through their task audits to discover what it is that they could be more efficient with. And we also have some of them talking about specific points. You can ask specifically about the people, you can ask specifically about the projects, you can ask about the theme, anything that you're interested in. It's really cool what you can do with having an LLM agent plugged into your internal resources. So yeah, thanks so much again for coming, and find me afterwards to chat.